right, students, we're really towards the last of the graphing of polar equations. A lot of what we're going to do in this section is doing some stuff on our graphing calculator with polar. Some of these things we're going to crunch out by hand. So to begin with, let's see, on this, we're going to look at several different types of graphs. The first thing we're going to look at, and we've already actually looked at this, is a line with a y-intercept of 0, and that would just occur when you have an equation theta equals something, and it can be in radians or degrees. Mainly on these, I'm going to put these in use radians on this. So the idea with these is you just graph, you identify the line and then you graph it. So if you identify pi over 2, what this means is this would be a line that would be vertical like that. So that would be your first line. That would be theta equals pi over 2. So once you identify that angle, then you just draw a line. Same thing with this one, negative pi over 3. Now that is negative 60 degrees because 180 over 3 is 60. So we would go down here, you would really just locate this angle right here. And then what you would do is just, shade in that pole. And then you got it. Okay, so you got like a 60 degree reference angle like that. So that would be the graph of theta equals negative pi over 3. So I'm going to have you do these. It'll only take you like 30 seconds to do these. So just go ahead and do these next two. And we're going to look at several different types of polar curve. Okay, so that's what you should have done. Negative pi is, of course, clockwise. So you end up shading the x-axis on that one. All right, the next one, 5 pi over 4 is here. So you end up shading that pole right there. That's 225 degrees, okay? So that's it. So that's the first kind of graph. Now we're going to look at circles that have a center of 0, 0. Again, we've already looked at these. So actually with these, it's real simple. What you do is if you have r equals some number, that just means it's all the points with a radius equal to that number. So this would be all the points with a radius of 5. So 1, 2, 3, 4, 5. Would just be around like this. So you would just draw a circle around like that and so forth. Okay? All right? So you can just sketch it. Sketch in that circle with a radius of 5 then. Okay. I'll try to do this the best I can. All right, it's kind of hard to get everything exact on this thing, but you get the point. Okay, you can just freehand it like that. All right, so that would be the graph basically of r is equal to 5. You have a radius going out 5 units like this. Now, it doesn't matter if you've got a negative radius, because if you were at 0 degrees, negative 6.5 would just be this way, away from that. 1, 2, 3, 4, 5, 6 and a half. So it basically would just be all these points on that ring like that then. So that's all there is to that. Again, I'll try to make this all pretty and everything. As pretty as I possibly can anyway. Okay, so again, you just sketch that in. That would be halfway, 6.5. in all directions like that, so just shade in that ring like that. Hey, that's not bad. Okay, all right, you get the idea. Okay, so that's what the circles look like on that then. Real simple. So on the next page, we're going to learn how to do some graphs and then some other kinds of circles here. So I'm going to show you how to do stuff on your graphing calculator. And I want you to be able to do some of these by hand, but some of the more complicated ones just on your calculator. The first thing you do is you do the mode button. You want to press your mode button. And I'm going to be doing these in radians. You can do them in degrees also, but all the problems I'm going to do in this section are going to be in radian mode. And then the other thing you want to do is move over to polar. You're probably right now in function mode. That's where you've been all semester. So move over to polar. Press enter, and then you're going to be ready to start graphing stuff in polar. Next thing I want to talk about is the window. And what you generally do is start at 0, you can go to as high an angle as you want to. I'm going to go 2 pi. 2 pi is probably going to be good enough for anything we're going to do, except maybe the spirals at the end of the section. I might change that. And then this theta step, you want that to be pretty small. If it's too small, it'll take forever to graph this stuff. If it's too big, then it won't look right. So 0.1 is pretty good standard. What I'm going to do on this is these polar graphs that I've given you, they go out to 8. They go out to a radius of 8. So I'm going to set up, you're really just setting up the x-axis like you would the radius. So that's going -8 to 8. So that's going from there to there. And then the y-axis, I'm going to do the same thing, -8 to 8, like that then. Okay, so you want to get your window set up. And then when you're ready to do something in polar, well, you do what you're used to. You go y equals, but what will happen is r equals will come out. So if we wanted to do the problems that we just did, for instance, if I put in r equals 5 and type graph, well, it draws the circle. Now, the reason that doesn't look like a circle, it looks more like an ellipse or an oval, is because of the way the window is. The distance between the notches on x and y aren't the same. So to make it look better, you can go zoom square, and then it looks the way it's supposed to look. Okay, so that's the idea. Same thing on the next problem. You go -6.5, put that in. It'll kind of look like that. Sometimes it'll leave a little gap in there. That's not intentional. It's just the way the calculator crunches that out. So you can put in polar graphs if you get everything set up this way then. And then this variable button is, that's where, when you put this in, that just gives you theta, see? So now that you're in polar mode, it's going to give you an angle theta. Okay, so let's move on to the next kind of graph is going to be the circles that have a center on the x or y axis. So it looks like this. If you have a cosine, the basic structure is either a cosine theta or a sine theta. The difference between the two is this. If you have a cosine, then the center is going to be on the x-axis. That's easy to remember because the cosine associates itself with the x value on a unit circle. And then when you have a sine, the center of the circle associates itself on the y-axis, and it depends on whether that value of a is positive or negative. So if a is positive, the center is on the positive y-axis. If a is negative, it's on the negative y-axis. And then the cosine works the same way. If a is positive, you're shifted over here, center on the positive x. If a is less than 0, you're centered on the negative x-axis like that. Okay? So we're going to crunch out a couple of these things with the benefit of the unit. Okay, so I want to just, use the unit circle to refer. We're going to fill out these values right here. So basically, we're just going to do 5 cosine of theta. So if we start with 0, cosine of 0 is 1. So this would end up just being 5 times 1, so that would be 5. And we're going to crunch these out first, and then we're going to plot points. We go to the next one, we have 5 cosine pi over 2. Cosine of pi over 2 is 0, so this is 5 times 0, so that's 0. The next one is 5 cosine pi. Cosine pi is -1, so we have 5 times -1, so that's -5. And then the next one is cosine 3 pi over 2. Cosine of 3 pi over 2 is 0, so that would be 5 times 0, so that's 0. Then we go back to 2 pi, it starts repeating itself, so that would be 5 again if you crunch that out. Okay, now what I'm going to do is we're going to graph these points. So we've learned how to plot points in polar, so if you graphed the point 0, 5, it would go 1, 2, 3, 4, 5 to the 5th radius. That would put your first dot. The second one, pi over 2, goes here. When you get to pi over 2, you're at an r value of 0. When you're at pi, you have a negative radius. Now let me kind of label these as I go. I like to kind of label that. That's the first point, second point, third point takes you back here again. Okay, and then the fourth point takes you, when you get to 3 pi over 2, you're back to 0, and then you're back like this. Now it's going to alternate with this, but there's these gaps in the middle like this. So we're going to do this on the graphing calculator, and I'll show you kind of how this goes. All right, so we're going to put in 5 cosine theta. What you're going to find is, since A is positive, the number in front of the cosine is positive, the center is going to be at 2.5. I'll show you that in just a minute here. So what's going to happen is, if you go over to halfway in between 5, the center of this circle ends up being at 2.5 like that. Then it's a circle. Okay, so that's the way that is. So like if I was to look at table of values, if you look at your table of values on this, this gives you different values in radians. So it's plotting all those points. You can also trace stuff out. So like if you wanted to trace like this, if you wanted to trace pi over 4, for instance, on this, well, then you would get that point 2.5 like that. So we're going to get some extra points by doing that. So if we're at pi over 4, then it looks like we're out at 2.5 like this. So pi over 4, we're out at the second ring, kind of like that then. It's kind of hard to get all this stuff put together. So basically it goes like this. You're going to go from 1, 2, 3, 4, 5, and halfway in the middle, you're really up about to the 2.5 ring like that. So the circle does something kind of like that, with the center being at pi over 4. No, not pi over 4. The center of the circle is not going to be traced out on the graph. The center of that circle can just be thought of as halfway in the middle like that. So that's how that graph goes. Okay? A lot of these things we're just going to do on our graphing calculator. The next one's a sine, so the center is going to be on the negative y-axis, and that's because that value is negative, like that. So again, if we went through and filled this out just with using the unit circle, and I'm going to get several values on this. I'm just going to go around and highlight the y value of several places, because what we're going to do is just plot these things basically in polar when we do this then. So you would end up having a point, the first one is negative 3 times sine 0. So that would be negative 3 times 0, so that's 0. The next one is negative 3 sine pi over 2. Sine of pi over 2 is 1, so that's negative 3 times 1. So that's negative 3. And then the next one, you can kind of start doing this in your head. This is negative 3 sine of pi. That's negative 3 times 0, so that's 0. And then we'd have negative 3 sine 3 pi over 2. That's negative 1, so negative 3 times negative 1 is positive 3. Then when we get back there, it gets back to 0. Now we have these extra points in here too that we can get with the 45-degree increments. So I'm going to start with plotting these points out. So when we're at 0 radians, the radius is 0. The second point, when we're at pi over 2, we're at negative 3. So you would be going 1, 2, 3 away from it. So that'd be your second point. And then when you get to pi, you're back to 0. When you're at 3 pi over 2, you're back here again, okay, at 3. So you're going to alternate between these 2 points, and the circle's going to be drawn around that. Now, if you were to go to pi over 4, for instance, if you go to pi over 4, this would go out, that radius, if you work this out, if you did negative 3 times the sine of pi over 4, you'd have negative 3 root 2 over 2, like that. So that would be putting you down in here. So these points, if you work them out, are roughly going to go like this. Okay? Now, and the thing about this is it's real tedious to do a table of values. I just want you to get enough of an idea on these graphs of how the points are changing, so that you can at least fill a few points out without your calculator. And then this one will go like this. If we put in negative 3 sine of theta and graph that, it'll do the same thing. So notice it's going down to negative 3, and that center of that circle is right down there, like that. Okay? And you can trace out points. So a good way to do this, to kind of get an appreciation for how this goes, is to just start by tracing at 0. And we get 0. And then just kind of go like this. If you press your right cursor key, see how the points just go around that circle, and they'll do that infinitely. So if you do that, that'll get you a little bit of an idea of how that traces through that circle. That's the idea, okay? Okay, so I'm going to have you do these problems. And again, all I want you to do is fill out the table of values by using the unit circle. Then I want you to do the graph on your calculator, just to kind of get an idea of how these go. And it's kind of good to make the connection of how they're centered. If you have a cosine, that's the center's on the x-axis. So I want you to see that. And the other thing is if the sine is in there, then the center is on the y-axis like that. So go ahead and pause and do these real quick. See if you get these okay. Okay, so you can go ahead and check and make sure you did your table right and then your circles right. And again, with your calculator on this first one is going to, the center is going to be on the negative x-axis because it's a cosine and that's a -8. So if you put this in, should graph like this, right? And you should have all these points right here. So you can trace to check your answer on these things too. So if you trace at 0, whoops, got to graph it, and then if you trace at 0, you get this. Okay, so you get -8, and you can do that, and you can go to the next one. You can go pi over 2. Okay, that gets you to that point, which is 0, and so forth. And then you can just kind of trace around that. Get as many points as you want to for as great accuracy as you want to. The center would just be at -4 right here. So that would be halfway in the distance right there. And then what I do is I know it's a circle, so I just sketch around that. So I kind of do this. I go 1, 2, 3, 4, and then just sort of trace. And then 1, 2, 3, 4, and then just kind of make sure that those are the height of the circle like that. Okay, the next one goes like this. If you graph this on the calculator, -6 sine theta. Again, what's going to happen on this one? It's going to center itself on the y-axis because it's a sine, and the center is going to be halfway between 0 and 6, so it's down at -3. Okay, same thing. You can trace, get your values like that. Okay, next one we're going to move on to looking at is the cardioid. So there's several different forms of a cardioid. A cardioid generally is going to look like this. It's going to be a plus, and I guess our textbook says a plus b cosine theta. That can be a plus or minus, or it can be a plus or minus b sine theta. Cardioids look like circles, except they kind of have a dimple in it. So they kind of look like a heart. Therefore, that's what we get then. Now, one thing that I was going to mention on this, when I record on here, I was going to show you, like, the microphone that I have has several different things on it. It has microphones oftentimes have a cardioid pattern. So like when I'm playing my guitar or I'm talking into the microphone I use a cardioid microphone, and that pickup pattern, follows. I speak directly into it like this, versus you can have microphones that are omnidirectional. So the pickup pattern is set up so my instrument goes directly into the microphone and my voice goes directly into the microphone. So I use a cardioid microphone to do that. And that has to do with the mathematics we're learning here. You don't really have to know the difference between the things. What I would probably try to get down is, if you have a cosine, the dimple is in the x-axis. And it just depends on whether the number in front of cosine is negative or positive. So if it's a positive cosine, it dimples this way. It's negative, it goes like that. Okay? And by the way, the numbers are the same. So notice on these problems, see how those numbers are the same? That's what makes it a cardioid. If you change those numbers, then it's a different type of pattern on that then. So what I'm going to do with this one is we're going to start off by doing some of this without a calculator, just to kind of get some appreciation for how the points go on this. So we're going to go ahead and do these two, get the tables filled out, and then kind of do the graph on the calculator then. So let's start with 0. So we're going to do r equals, on this we'll start with 3 plus 3 cosine of 0. Okay, and again I'm just going to highlight the x value around the unit circle, and then we're just going to do some simple number crunching. So this would be 3 times 3 times 1, so that would be 6. So we'd have a point 0.06 in the polar coordinate system. Then we're going to move to the next one, 3 plus 3 cosine pi over 2. Okay, that'll be 3 plus 3. The cosine of pi over 2 is 0. So that will be 3. So that gives another point. Then we go to pi. So we'd have r equals 3 plus 3 cosine of pi. Cosine of pi is negative 1. So we get 3 plus 3 times negative 1. That gives 0. That's where the dimple kind of comes together. And then the next thing we'll look at is 3 pi over 2. So we have r as 3 plus 3 cosine 3 pi over 2. So that's 3 plus 3. Again, the cosine of 3 pi over 2 is 0. So that'll give 3. And then when we go back here, it'll be the same thing. Since those angles are coterminal, then that will repeat itself again like that. So what we'll do then is we're just going to plot these points, and then we'll use our calculator to get some other points on this. So we start with, at 0, we go out to 6. So 1, 2, 3, 4, 5, 6. That's point number 1. I like to label the points, number them as I go. We go to pi over 2. So we go to 1, 2, 3. That's the second point. Sometimes this thing doesn't behave and doesn't want to put points. It thinks I'm doing something else. Okay, so that's the second point. Third point is pi 0, so it goes like that. So that's the third point. Fourth point would be 3 pi over 2 down here, and then out to the radius of 3, kind of like that. And then it repeats like this. So these points, it'll repeat over and over again. So what happens is it's kind of like this. So the graph, and let's go ahead and just put this in the calculator so we can get some extra points. I mean, you could do as many points as you want to, but it's best to just get the idea of how the basic points work and then fill it in with your calculator. So I'm going to put in the 3 plus 3 cosine theta and graph that. So that's what that looks like, is like that then. A couple other things that'll happen, like if I traced at pi over 4, that ends up giving you a point that's about 3.6, so that's kind of worth doing on there also. So at pi over 4, you're out about to the third ring and a little further, kind of like that then, okay? So you end up just kind of sketching these points like this, so it basically does something kind of like this. It'll kind of do the dimple thing like this, and then go through the points kind of like that, okay? It's not perfect, but you get the idea, okay? All I want is just kind of the basic idea, all right? Okay, the next one, let's fill this out. Okay, the same way, just repeat everything but use the sign on this. And again, we're doing the y values on here. It's not bad to take a few extra points on here too, so I'm going to maybe use the halves on those because those are kind of nice points to use as well. Okay, kind of like that, so we'll get a few extra points. So let's start off, we'll have r equals 4 minus 4 sine of 0. Sine of 0 is 0, so that's 4 minus 4 times 0, so the first point's 4. Okay, like that. Then we move on to, let's go actually to pi over 6, just for something different. So we'd have 4 minus 4 sine pi over 6. Okay, that would be 4 minus 4 times a half. So that would be 4 minus 2. So that would give a point with 2 like that. And let's just kind of plot these as we go. So the first point would be 0, 4, you'd be at 0 radians, and you would be out to the 4th point. Then if we go to pi over 3, then we're out to the 2nd one like that, kind of, okay? Then we move on to pi over 2. So we'd have r equals 4 minus 4 sine pi over 2. Okay, well that would be 4 minus 4 times 1. So that's 0. So then we would go like this. That'd be like kind of the 2nd point. This would be the 3rd point like this. And what's going to happen is the thing's going to kind of go in like that and dimple in sort of like that roughly. Okay, let's go to this point. Let's just crunch this one out since it's easy. So we'd have r equals 4 minus 4 sine of 5 pi over 6. So that would be 4 minus 4 times a half. So that would be 2 again. So what you would get is at 5 pi over 6, which I can hardly see on here, which is here, you would end up being at 2. So that would be 1, 2 like that. Okay, so what happens is it kind of goes up to that point like that. And then if we go to pi, we have r equals 4 minus 4 sine pi. Sine of pi is 0, so that's 4 minus 4 times 0. So that's 4 minus 4, so that's 0. So when you get to pi, whoops, I think I did that. No, that's 4, that's 4 minus 0. I knew I did something wrong. So that's 4 minus 0, so that's 4. I think I'm thinking ahead there. So that's 4. Then it goes like that. So that point would be at pi, you would be out to the 1, 2, 3, 4th ring like that. And you can kind of see how the cardioid, how it kind of dimples around that like that. And then if you do the rest of this, if you do this one, that would just be 4 minus 4. The sine of 3 pi over 2 is negative 1. So that would be 4 plus 4, so that would be 8. So you end up with 3 pi over 2, 8. So you're here, you go to the 8th ring like that. And that's good enough. You kind of get the idea of how that goes like that. All right? It's kind of tedious to plot all these points, but I do want you to understand what the graphing calculator is doing really in polar. Okay, so I'm going to put this one in. And again, what I'll do on this, just kind of to check and just show you how this traces out. So what happens is it dimples around the y-axis like this. So I do 4 minus 4 sine theta. And that's the same thing we got. We did a couple extra points to add to the accuracy. Again, if you start by tracing at 0, and then if you just press this, it'll at least kind of give you a feel for what's going on the problem. You'll see kind of the order it's going through. As the angle gets bigger and bigger, the radius is changing. So that's the idea. That's worth doing. Okay? All right, so I'm going to have you do a few cardioids. The idea is fill out the table of values. You don't have to do the extra points unless you want to, but just try to fill out the table by hand, plot those points by hand, and then use your calculator to fill in the rest. Okay? So pause, come back and check. Okay, so you can check and see if you got all your arithmetic right and your graphing right. So I'm not really going to go over this too much. Just make sure that you did your unit circle, your number crunching, and your table right, and then plotting your points. And you can check these things on the calculator so you can see if you're right. So pause if you need to look over this or anything, and otherwise I'm going to go ahead and move on to the limacon. Okay, so the limacon would be, what's different on this is you change the value of A and B. All right, so what happens is A and B are not the same. So in the previous problems, these numbers are the same, 3 and 3, 2 and 2. When we change those, then you get a limacon. Then the limacon either dimples in a slightly different way than a cardioid does, or it has an inner loop to it. And you don't really have to know all these different cases right here. This is just information for you to look at. So the idea on this is basically on this, the cosine dimples on the x-axis, the sine kind of dimples around y, like that, and then it depends on the value of a and b, which is bigger, basically, is kind of orients itself like that. And what happens on this is a is generally less than b on this, and if a is greater than b, then you'll end up having that inner loop like that. But you don't have to know which is which. This is just mainly for reference for you. I'm also going to do these on the calculator. Okay, so I'm going to run through on this, and we're going to do the table of values on these also, because they're not too hard to do, just to kind of get a feel for how these things graph out then. Okay, right? So what I'm going to do with this one is notice on this that the numbers are different. 2 plus 4, 4 minus 3. So we'll kind of see which is which on this. And it depends on which number is bigger. This one is going to kind of do the dimpling. That's going to have the inner loop, because if 4 is greater than that number 3, then it kind of has that loop. And since 2 is less than 4, then it does the dimple. Okay? Right? So let's go through and just get these kind of worked out then. So we're going to do a cosine. So I'm going to basically just use these values here and crunch these out. So if we had cosine of 0, so we'll start with r equals 2 plus 4 cosine of 0. Cosine of 0 is 1, so we'd have 2 times 4, 2 plus 4 times 1 would end up giving 6. Okay, so that first point is going to be at 0 and then out 1, 2, 3, 4, 5, 6. So that's where the graph starts. Okay, the second point, we'll do r equals 2 plus 4 cosine pi over 2. Cosine pi over 2 is 0, so it's 2 plus 4 times 0, so that's 2. So we'll plot that point. We go to pi over 2. We go out to the second, like that. Okay, and then we'll just keep crunching on here. Go to pi. So now we have r equals 2 plus 4 cosine of pi. Cosine of pi is -1, so this is 2 plus 4 times -1. 2 minus 4 would be -2. So what happens on this one then, you go to pi, but if you end up having the radius of -2, then you end up over there. Okay, that's kind of where that loop is going to go on that one then, like that. Okay, so that's the third point. And then when we get to the fourth point, we'll do 3 pi over 2. So we'll have r equals 2 plus 4 cosine 3 pi over 2. That's 2 plus 4 times 0, so that's 2. So this point, when you get to 3 pi over 2, is going to have a positive radius towards that, so it goes like that then. So those points are going to kind of loop through kind of like this. And to see this, let's go ahead and just put this in the calculator. So we have 2 plus 4 cosine theta. The fact that those numbers 2 and 4 are different is what makes it a limacon. So we graph that, you have that inner loop. And if you were to go through and trace starting at 0 and just kind of look at how this goes, it will kind of show you how it loops, goes through that inner loop right there, all the way until you get to 2 pi. So all you're going to do on this is just sketch this, okay? All right, so we'll go kind of like this. So it basically comes around, it looks like that high point is about 1, 2, 3. It's roughly gets up around kind of like in there. And then it goes through that point, loops through kind of like that, then comes back like that. Okay, so it's a good idea when you're doing these graphs just to trace it out to do that then. You could also, if you really wanted to make this super accurate, you could go through and, you know, plot as many points as you wanted to. You can even set up your window in a certain way, and I'm going to show you that in a few minutes anyway. Okay, so let's do the one, this has got a sine in it. And that one I think I said backwards. I may have said that. Since the 2 is less than 4, that's why that one has an inner loop. The next one will not have an inner loop. Okay, so let's crunch this one out. This time it's just the sine. So I'll go around and highlight all of the y values, and then we'll do the sine. Okay. All right, so let's see. We're going to do r equals 4 minus 3 sine of 0. So that would be 4 minus 3 times 0, so that's 4. So our first point would be at 0 radians. The point goes out to the fourth circle. Okay, then we go to the next one. We'd have r equals 4 minus 3 sine pi over 2. So that would be 4 minus 3 times 1, so that's equal to 1. So you'd have pi over 2, then you'd be out to 1 like that. So those are your first couple of points. Then we move to pi, so you would have r equals 4 minus 3 sine of pi. That would be 4 minus 3 times 0, so that's back to 4 again. Okay. Okay, and let's see. So we'll take that. Now the way this one goes, you're out at pi, so it would go 1, 2, 3, 4 out like that. So that would go like that. And then we'll move on to the next one, which is, and I'll just do this over here at the side somewhere. So we have r equals 4 minus 3. Oh, God, are we going? Oh, another power failure. Sorry. Where I live, it's real windy. And sometimes when the wind kicks up, it messes the power lines up. We did that, had a power failure yesterday. But anyway, I think I'm still in good shape here because still got battery juice in my computer here. So we'd do sine of 3 pi over 2. Light's back on. So 4 minus 3 times negative 1 would be 4 plus 3, so that would be 7. So 3 pi over 2, we'd go to 7, so that would be all the way out there. That'd be the fourth point. Okay, and then it would just repeat itself. Okay, I didn't really put that on the last one because since those angles are coterminal, you're going to be kind of like at the end of the period on this then. Well, let's put this in the graphing calculator so we can see how it goes through these points. So this time we have 4 minus 3 sine of theta. And it goes like this. So you need to kind of look at your calculator to get a feel for how that goes. So it kind of dimples, kind of like that. Kind of looks like a cardioid, but it's really not a cardioid. And then it goes through these points, kind of like that then. Okay? Again, trace it. Just kind of get the appreciation for, as the angle gets bigger, how it traces through those points like that. Okay, that's the idea. Okay? All right, so let's see. The next thing, I'm going to have you do these. Again, just kind of one more time, we're going to do the table of values. The rest of the graphs we're just going to do totally on the calculator. Okay, and I don't expect you guys to do these problems totally by hand. I want you to do these, get the idea of how the table of values goes, get the idea of how the points work, and then use your calculator to get it accurate. Okay, so go ahead and pause and do these. Okay, so you can go ahead and check the details. You can pause. You just want to make sure that you double check your calculations on your table. Since you're doing this on the graphing calculator, and you can check that too. Here's how the last graph went. So if you trace this out starting at 0, it goes like this. So it starts, whoops. Okay, so I've got that. Trace at 0, so it actually starts at negative 3, and then if you start going through this, oh, my calculator's all messed up. Need to reset my window. So check over this while I'm fixing my calculator, and then see if you got everything right. Correct anything that you did wrong, but I'm not going to go over these too much. Okay, so I'll do that. And then it'll trace through that. So if you start by tracing at 0, I give you that. Okay, then you can go through and that'll show you kind of how it loops through that inner point and so forth. All right? So that's the idea. If you go zoom square like this, that's more the way it's supposed to look. And sometimes this window changes on these things on me when I'm doing this. Okay, pause if you need to, otherwise you're going to move to the next page, and we're going to do the rest of these on the graphing calculator. Okay, so next thing we're going to look at is a lemniscate. Kind of looks like an infinity. The structure is r squared equals some number squared, cosine of 2 theta or sine of 2 theta. Okay, and it kind of orients itself. You don't have to know all these things right here. It's just good to know the basic shape and then how to do this on your calculator. Now what you have to do on these is you have to do the square root of both sides. Right? So when we put this in our calculator, which is all we're going to do on this, is just put these in the calculator. I'm going to go back and I need to adjust my window again. So I'm going to go like negative 10 to 10 by a scale of 1 like that. And we'll put this in like this. So you want to do square root and just put it in like it is. I need to clear this off first. So square root, put in the 25. You don't need to do the square root. Just let the calculator take care of that. And then cosine of 2 theta like that. Okay, so if we graph that, that will be the first case. Okay, since there's a cosine and since this is a positive number, so if A is positive, like it is there, then it's going to look like that. Now all we're going to do is just plot points. So what will happen on this, you have a point 0, 0 in there, 1, 2, 3, 4, 5. When you do the square root of 25, you get 5. So what that means is on the x-axis, you're going to go out 1, 2, 3, 4, 5. That gets a point. You could actually number crunch this with a table of values to see this too. Then you'll end up kind of having 1, 2, 3, 4, 5 to the left. And then let me just trace this so you can see how this works. I'll start by tracing at 0, and it gives 5. And then you can kind of see how it traces through these points. There is no gap there. It looks like there's a gap, but there isn't. Okay, this is always defined. So it just basically, you're just going to go through this loop kind of like this. So what it does is it kind of goes, and I'm going to do that trace one more time so I can show you the order it goes through. So it kind of goes, why does it do that? Anyway, okay, go through and just kind of sketch it out. So it'll kind of go like that, roughly like that. Okay, it doesn't have to be perfect, but you can see on your calculator how that works out. Sometimes when I trace, it just decides to change the window on me for some reason. Okay, so that's how that one looks. Okay, next one we're going to do the same thing. We're going to put in, just do square root of both sides. And we should be able to just type over this. Now this one will be this case. So it's got, this case right here, whenever you have a sign, it kind of goes at a slant. So this one should look like this one with A being a positive number on that. So what we'll do on this one, just type over this. We'll put in a 36, and then we'll put the sine of 2 theta like that. So just put that in like that with the square root, graph it, and that's going to look like that then. So what kind of happens on this one is it starts at 0, 0. I'm going to start by tracing at 0 and then just kind of move through these points like this. Okay, so it'll eventually kind of get up through these points. The high point gets up close to 5, okay, and just kind of, all I want you to do is just give a sketch on this one. So it kind of goes like this. The height is close to 5. Kind of like in here, so just kind of make a rough sketch, kind of going like that. And this low point out here will kind of be out at -5, kind of like that. So it roughly kind of looks something like that. Again, it doesn't have to be perfect. You can see how it goes on the graphing calculator. All right, and how that traces through those values. Again, there's no gaps. Everything is defined, okay? Right, so do the next two. Just do these on your calculator. Just get a rough graph on these then. Okay, so this is kind of what you should have. All I want you to do is just kind of looks like a peanut is kind of what it reminds me of. So again, it's basically if you have a negative number and it's a cosine, then the infinity orients itself this way. Sine's always at a slant. And since that's a negative, it orients itself like that. There's no breaks. They do connect. Okay, so that's what you should have. This one, too, you can get pretty accurately. That should go up to a radius of 6. Down there you have a radius of 6 also, like that. Okay. Right, on the last page, we're just going to put these in the calculator. Two other kind of things I want to show you. There's the Rose curve. So if you have r equals a cosine n theta, or if you have r equals a sine of n theta, it goes like this, and I'll show you how the leaves go. Okay, so we're just not going to graph these. We're just going to put these in the calculator. All right, and I'm not going to have you do any problems. We'll just do these together. So what happens on this first one? If you put the first one in, you have 4 cosine 3 theta. So it's got an odd. If this number is odd, that'll tell you how many leaves it has. So basically, this one is it has 3 leaves. Anytime that's an odd number, that's how many leaves it has. So this next one's going to have 5 leaves like that. And that's kind of what that looks like. I'm just going to slide these over here and label these as I go. Okay, so that's the first one. You don't have to draw the graph on these. So this is r, I'll just put, this is r equals 4 cosine 3 theta. A couple of things on this. Notice this thing goes out to a radius of 4. That's the significance of that number, like that then. And let's see, the next one, I'll put that one in. It's got an odd number, so it's going to have an odd number of leaves. So we go 6, and then this time it's sine of 5 theta. Put that in, it's going to have 5 leaves. Okay, looks like a starfish. Okay, so that would be the second one. Okay, that one goes like this. I guess the significant thing on that shows that the radius is 5 at that point right there. Then what happens on this, if they're even, if this number right here is even, then the number of leaves gets doubled. So this one will have 8 leaves. This one will have 16 leaves. Okay, like that. So let's put them in and see if that is indeed the case. Okay, so the third one, we just go 4 cosine 4 theta. So it's got 8 leaves. Kind of cool. You know, if you look at, like, I think it's a sand dollar. You know, you go to the beach and look at a sand dollar, they kind of look like rose curves. A lot of things, petals on flowers, kind of follow this pattern a lot too. So a lot of this stuff shows up in nature, believe it or not. Okay, not that the flower is, you know, plotting out a polar graph. It's just something is programmed in the molecules to do something in a certain way and get the number of petals. Right, so let's see, this next one goes like this. This would be 6 sine 8 theta. Look at that, that's got 16 leaves. Okay, like that. Isn't this cool? This stuff's great. Looks like the little toy I used to play with called a spirograph. I love these polar graphs. So that's kind of how that looks, all right? All right, so again, I just want you to do those on your calculator. Get a little bit of appreciation for how they go. And I want to show you one other thing on this problem I just did. If I was to make the theta step smaller, like make it 0.05, then it really looks better. This is more the way it looks, is more like that. It's got more of, the smaller you make that theta step, the more realistic these things look. So that's how that goes, okay? So just these things get cooler and cooler as you go. If I wanted to make that 16 theta, then this sucker is going to have 32 petals. Isn't that amazing? That is so cool. All right, polar graphs are just really cool. All right, so let's do the spiral. I'll show you how to do the spiral. The spiral is r equals theta. All right, so let me just have you put this one in the calculator. And what we're going to do on this is we just put r is equal to theta. Now, if we graph that, it isn't going to do much. It'll just kind of show you the beginning of that spiral like that. I'm going to have you do a window. What we're going to do on this is I'm going to change this to, like, instead of 2 pi, let's go 10 pi. So you can kind of get a sense for how it goes. I'll leave that at 0.05. And let's expand this out to like -50 to 50. Okay, kind of like this. All I want you to do on this is just try this on your calculator, just because I think it's so cool. Spirals are cool. Spirals show up, spiral galaxies, shells on the beach. They follow spiral patterns. Okay. So if we do that, I'm going to slide that window over there so you can do that. Look at that. Okay, it does that. Keeps spiraling. Now my window would have been better if I would have done Y scale by 10. So it goes like that. Okay, just keep spiraling, and you could make that angle get bigger and bigger and bigger, and that's how that spiral goes. So that is way cool. All right, guys, that's probably the end of what I want to show you on this. Just want to give you a little bit of an idea of how these rose curves work a little bit better. And that's it. There's all kinds of polar graphs that you can do. You know, it's kind of fun to just play around with stuff in polar. So like if you just want to goof off a little bit with stuff and try stuff like putting in some random numbers, I'll do something like this. Sine of 2 theta, cosine of 4 theta. Who knows what's going to come up? Just play with these things. Well, that's not a very exciting one, is it? Let me go back to doing a window. Just go back to 0 to 2 pi. Because I just want to kind of encourage you to play around with this stuff a little bit. So let's go back to something like negative 10 to 10. That's why the graph of that turned out so weird. But I've come up with all kinds of stuff on this. You can go, if you're interested, you can research a little bit online and find all kinds of cool stuff on here. Okay, so that's how that one goes. And just kind of go through and play with stuff, change numbers around, see what they look like. Okay, look at that. Isn't that a funky looking? That looks like a moose. You can go like this, zoom out. Okay, that didn't do any good, but you can play with it a little bit and you'll find all kinds of fun stuff on there. Okay, so that'll wrap up this video.